Hello everyone, today I am here for presenting my mini project entitled as Atterberg's Consistency Limits and Unified Soil Classification System, an in-depth exploration of soil behavior and classification in geotechnical engineering. So let's have an introduction of the topic. So basically, soil classification is very essential factor in a geotechnical engineering as it provides the key insights which are very essential for soil properties, identifying the soil properties, its behavior, and which directly influence on the design and construction. Accurate classification ensures the safe and efficient engineering practices, reducing the potential risk or hazards which are associated with the soil instability. So nextly, we'll identify the role of consistency in soil behavior. Soil consistency plays a very crucial role in predicting how soil will respond under certain kinds of moisture conditions. Understanding the plasticity, liquidity, and shrinkage limits helps engineers to assess the potential risk and hazards which are associated with the various kinds of designs and which are suitable for the foundation and earthworks. So nextly we'll have an overview of the Atterberg's consistency limits. So Atterberg's limits which are developed by Albert Atterberg which defines the critical moisture contents at which soil changes its state from one state to another. These limits offer the vital parameters that inform soil classification and behavior essential for effective geotechnical analysis. Unified Soil Classification System USCS. Unified Soil Classification System USCS categorizes the soil based on particle size distribution and Atterberg limits. This systematic classification is widely utilized in engineering for assessing soil behavior, supporting the effective project planning and design. So nextly, what are the Atterberg's limits? So basically these are established by Albert Atterberg. We have identified it earlierly. So determining which determines the behavior of the soil at various moisture conditions. These limits classifies the soil into categories that help to predict the behavior during engineering and construction process. So types of Atterberg limits. So there are basically three types of Atterberg limits, that is liquid limit, plastic limit and shrinkage limit. Each limit categorizes different moisture contents where soil transitions through various states and consistency in behavior. So nextly we'll see the first Atterberg limit, which is liquid limit. So it is the minimum water content at which soil behaves like a liquid or soil flows like a liquid state. So this is a critical for understanding the flow behavior in the saturated soil. So next state is a plastic limit. So plastic limit marks the water content at which soil changes its state from semi-solid to the plastic condition. So it is the minimum water content at which soil behaves like a plastic. So it is very essential to determine how soil handle the stress and deformation. So nextly we'll see the shrinkage limit. Shrinkage limit is the water content below the which further moisture loss does not leads to decrease in the soil volume. So this is a very crucial to understanding long-term stability and shrinkage swell potential in soils. So from which we have to derive one kind of index which known as a plasticity index. It's nothing but the difference between liquid limit and plastic limit. It indicates the plasticity range from the fine-grained soils, which is very crucial for classification purpose. So here are the various methods for determining the limits, plastic limits of the soil. We'll see one by one. So Casagrande's, so first method is a Casagrande's method of liquid limit determination. In this, Casagrande's cup method, which involves the dropping of the standard amount of soil mixture into a cup, measuring the moisture content at which it flows like a liquid. It's a widely accepted method for at determining the liquid limit. It's a very standard method which is used to determine the liquid limit at laboratories. So next one is a rolling thread method. The rolling thread method requires the rolling of soil sample thread until it crumbles. So it determines the plastic limit crucial for characterizing the fine-grained soils and their plastic behavior. Shrinkage dish method. So shrinkage dish method is it involves observing the volume change of the soil sample as it dries in a shallow dish. So we can see here this is a shrinkage dish. Uh, it determines the shrinkage limit, informing about the potential shrink swell behavior in soils. So nextly we'll see the Unified Soil Classification System, that is USCS. So USCS is developed by US Army Corps of the Engineers. USCS classifies soils into specific categories to guide the engineers in soil analysis. Its widespread use ensures the consistent communication and understanding the soil properties across the various kinds of projects. So classification criteria. Soil classification in USCS relies on grain size distribution and Atterberg limit for fine grained soil. The symbols such as GW, GP, CL provides the essential and shorthand for communicating complex soil characteristics in design and analysis. So identifying the soil type includes the visual manual procedure along with the laboratory testing like sieve analysis and Atterberg limits. This is a comprehensive approach which ensures the accurate soil classification and behavior prediction. So nextly we'll see the very crucial and core concept, that is ice plasticity chart. Ice plasticity chart is a graphical representation used to classify the fine grained soil. So here we can see that on x-axis liquid limit is denoted in a percentage, and on y-axis a plasticity index, that is a difference between liquid limit and plastic limit in a percentage. It is denoted. We can see a inclined line which is known as nothing but a line, which have an equation that is 0.73 into liquid limit minus 20. So this line bifurcates the clay and silt together. So here is the importance of the ice plasticity chart. So at conclusion, Atterberg limits plays a vital role in identifying the soil behavior by establishing the consistency thresholds and different moisture levels. The liquid limit, plastic limit, and shrinkage limit helps to classify the soil based on their plasticity and moisture content, and thereby adding the accurate geological assessments. So, unlike this, a USCS, that is Unified Soil Classification System, categorizes the soil basis on the grain size and plasticity, providing a systematic approach for engineers. This classification is very essential in designing the foundation and earthworks, ensuring the structures withstand a varying soil conditions effectively. So basically, Atterberg limits and USCS are both indispensable tools in geotechnical engineering. Their applications not only aids in understanding the soil behavior but also enhances the safety and performance in construction projects, leading to the more resilient infrastructures. Thank you.